So Jan Raack, welcome to the studio. What do you think of our audience's ideas? Aren't they creative?
Of course, yes. So I joined the online chat a couple of minutes.
I hear you've been doing very well.
Yeah, it was
Bringing
my first
some
time.
sense to the conversation, I
a
hear.
little bit science, yes,
Yes.
but not so much, yes.
No, that's brilliant. No, thank you. What's it like then for you? I mean, you're an academic at the Open University. Mm-hmm. You've been here and not since very long, so you started here in March, so it's all been quite new. What's it been like talking with, and we've got a lot of science students out there, what's it been like as an academic then, talking to everybody in this sort of environment? How have you found it?
A little bit weird, to be honest, because I was a student a couple of years ago too, and for me it's a step further from student to ask questions, to answer questions. So for me it's really new, and I excited it, really, and I enjoyed it, yes.
Excellent. You're now doing a lot of research. So you were from Germany and you've now come to the Open University here in Milton, sunny Milton Keynes.
Sunny, yes.
Exactly. Well, not really, is it? We won't lie. You're looking about surface activity on Mars. So we've just been talking to Rhian about the lander. And obviously this has an impact in terms of what we will know about the surface. But as John was telling us, the Trace Gas Orbiter also has a lot of instruments that are going to take various measurements that will give us more knowledge about the surface. So in terms of this whole thing, then, the Trace Gas Orbiter and lander, what can we say then about your specific area of research in terms of what you're looking at for the surface of Mars?
At the moment, not very much, because the Trace Gas Orbiter has a very good camera on board, and I'm working a lot with remote sensing data sets from cameras and spectrometers. The camera has a very good resolution, up to 5 meters per pixel, and it also can get very high resolution color 3D images of Mars. But the first images, I think, will arrive the Earth in 2018, so after the breakup, and maybe at this time I'm not here in Milton Keynes and I have no idea where I'm working then, and if I can get these images.
Wow, so that's going to take a lot longer.
Yes.
Why?
Because at the moment the Trace Gas Orbiter is too fast, and it has to go around Mars, and it becomes slower, and it takes over 1 year, and after this the camera starts and everything is working fine.
So it's about the phase as opposed to actually getting the resolution of images back down here. Yeah, OK, excellent. So can we start talking about what we already do know then in terms of the surface? Because this is something that I guess most people are very interested in, especially if they're looking at, you know, whether life on Mars is possible or even has been. So what do we currently know then about the Martian surface?
A lot, I think. So we know a lot of the history of Mars, but I would say the history of Mars is like you read a book, and you read a book not page by page or sentence by sentence. You read it on page 100, sentence 2, and then page 50. So not in the right order. And at the moment, we are putting here all the things together to get the history of Mars, to read the book completely from the beginning to the end. And with every single image, with every single Mars mission, we get more information and to have a better clue about what's going on Mars, or what's happened on Mars billions of years ago. So this is what we are doing. We are scientists who put the puzzle together.
One thing I know about Mars is it's called the red planet.
Yes.
So what's all this redness about, and what's that got to do with the history of the climate and surface?
Normally the rocks are not very red, so the surface is red. This is oxygen because of the interaction of the rock with the atmosphere, and when you could grab on the surface, it's grey,
right,
under the reddish surface color. Yes.
Okay, so
like the moon, maybe then.
Yeah, so it's mainly grey, but the bits of red, they're there to do with the rocks and things.
Yes.
And then I guess, you know, we've been talking a little bit about how we interpret and have these various ways. Is the redness then just a sort of media concept of Mars then?
Sorry, what?
Just thinking about how we were talking about how important it is for media to represent space in certain ways. So we were talking about extraterrestrial life and the Martian and whether being blown away was an indication. Is the Mars, the red planet, is that more a media interpretation to make nice models and to say that as opposed to the reality, because a lot of it is grey, as you say?
I have not really a clue what you mean. So
no, that's fine. No, gosh, no. It's fine. It's more just a point, I guess, about how sometimes I think, especially if we're looking at things, we cotton on to something very small and often not very accurate when we're describing something. And maybe that's the case with Mars being called the red planet. We know
it
more,
is red, but
only just on top of the surface. So it's not really, really red. Yeah, no, perfect. Okay, we've also been talking about what it might be like to exist in that atmosphere, and that it's generally very cold. We've talked about the carbon dioxide and the air quality not being so good, etc. So we also know then that there have been lots of volcanoes and craters and things happening over time. What do you think then is most interesting about that Martian surface?
At the moment or in general?
In general.
In general. Now, there are two parts which are very important. So the first part is the search for life, of course. It's the most important thing. And when we do the search for life, we have to look at the very old rocks where we can maybe find some micro fossils. So we have to look at the old rocks on Mars. And we can find it on Mars. On the other hand, it's also very interesting to look on what's happened on Mars now, not in terms of life, but in terms of activity. And we have activity on the surface on Mars, but it's only recognized in the last couple of years. So because we need a lot of, for example, a lot of images to cover and to see these activity on Mars today, yes.
These rocks then, some of the old or new ones, how do we know if they're old or new? And do we need to drill to get hold of any, or are they on the surface?
They are on the surface, but it's very difficult to know if this is old or new. We cannot go there and say, okay, this is an old rock or this is a new rock or whatever. So the interpretation is more like the age of the surface. Right. So we look at the surface, we count the craters on the surface, and then we can say, okay, it's an old surface with a lot of craters, it's a young surface with less craters. There are some equations where you can fill in these data sets, and then you can say, okay, this formation of rocks is maybe 2 billion years old. Then we can find maybe something more on it.
Because one of the things that I know you wanted to talk about was the sort of historical overview, because we've created these wonderful names for these various periods throughout the history, and you've got the Nocation period, the Hesperian period, and the Amazonian period. So can you tell us, those are categorised by quite different environmental changes, aren't they?
Yes.
So there were differences in terms of the atmosphere, and we've already seen that the atmosphere has dramatically changed. So it was a lot more like Earth's environment than it is now. Could you talk us through some of those? What's most interesting about those periods, and how does that translate?
Interesting is every period of time. So the first period is from, I think, 4.5 billion to 3.7 billion years, and it's for the search of life, it's the most interesting period of time, because Mars was habitable in this early days of Mars, or early years of Mars. There was water stable on the surface. The atmosphere was denser than today. Mars had a magnetic field, so it shields it from the sun radiation, and it was very comparable to the early Earth. So like Matt told us in the introduction, it is possible that life forms existed in the first time. But then something changed Mars in the Noachian time. Something changed. Then we have a lot of volcanic eruptions all over Mars. We have the loss of the magnetic field, and because of this we have the loss of a lot of the water, and the atmosphere was full of sulfur. And this stopped, I think, 3 billion years ago. And then normally the scientists say that from this on Mars was a dry and cold and dead planet. But this is not true, because in the last couple of years we saw activity, or we see actually activity on the surface. So yes, it's a dry and cold desert planet, but it's not dead. So we see something happened.
So were those changes, I mean, on Earth, when we look historically at the Earth's environment, we have ideas about what may have happened to cause massive shifts. Are there any theories around any of those changes?
I'm not sure, really.
No. But they were just very, very different, and we've seen massive, massive changes over time.
Yeah.
One thing I wanted to ask you about is these some of the reservoirs. So we've been looking at some. We've talked a little bit before, and I don't want to repeat about some of the lakes, etc. and things. But the large reservoirs of volatiles at the poles and polar caps. There are massive changes going on there at the moment, aren't there?
Yes, seasonal changes like on Earth. So it's like the breathing of Mars. So we have an annual waxing and waning of the polar caps. So we have two types of polar caps. We have the residual polar cap, which is stable and it lasts every time. And we have the seasonal polar cap. So ice sublimating, going to the atmosphere, traveled around Mars, settled down from the south polar to the north polar regions, settled down, and then when the winter came, it sublimates too, and so on. So we have a very good volatile circle on the Mars, which is completely different on maybe the Moon, where there's nothing. So.
We've been talking a lot about the red planet. Sorry to trigger such a conversation about that. And these dust storms are clearly important. Yes. But also, I wanted to conclude by talking about some of these dust devils, which is an area of work you've been very interested in. They leave dark, bright tracks on the surface of the Moon. So what are they? They're an unsolved mystery, aren't they?
It is solved now.
Oh, you've solved it now?
Yes.
OK.
Dust devils are very weird. So dust devils are known on Earth since hundreds of years. So everybody knows dust devils.
Yeah.
They are small whirlwinds on fields or whatever. And on Mars, it's a very funny story, because on Mars, in the 70s or 80s, they detected some weird structures on the surface. So bright tracks and dark tracks, and they have no idea where they are coming from. And later, in I have no idea when, 2000 or so, 2001, they, with a better and better camera resolution, they saw, okay, they are dust devils on the surface of Mars, and they leave tracks.
Right.
Yes, but it was a mystery. Why are they bright and dark tracks on the surface? Because on Earth, there are no tracks, or there were no tracks. So then something happened, that the scientists are looking at the surface on Mars, on Earth, and look for dust devil tracks the first time. And they found some dust devil tracks on the Earth too. So they found something new on Mars, then looked onto Earth, found it too. But it was in Niger, where the Civil War is, and you cannot go there and make science. So 1 year later, they found the proposed mechanism of the dust devil tracks on Mars with the rover. So the rover drove over the surface, found a dust devil track, put the microscopic camera on it, and see, okay, there is less dust in the dust devil track. So the dust devil blow away the dust on the surface, and it is seen by the tracks. And then on, it was my colleague from me and me. We are looking again at Google Earth images on the Earth, and we found also dust devil tracks in China. Then we packed our backpack go to China in the desert and detected the dust devil tracks for the first time ever on Earth. And we can prove the proposed mechanism for Mars and for Earth. So it was the first time, I think, that something very new was observed on Mars, and then we put our knowledge from Mars to Earth. So
excellent. So very, very comparable in terms of the planets as well,
yes.
and Mars actually adding something that we could then use to investigate here and then apply.
Yes.
Excellent. That's brilliant. We'd asked our audience, is it true that space missions to Mars fails because some engineers use metric measurements for their calculations and others used imperial measurements? 67% of that thought that was true. Is that right?
Yes, that's true.
Okay.
That's sadly true. It was in 1999 where the NASA mission, it was a Mars climate orbiter, I think, yes, where the NASA mission, the NASA scientists are working with a metric system, but the Lockheed Martin, the company who built the navigation system, are calculating with miles and so on. And what happened? The Mars orbiter crashed completely into Mars, and that was all. So since then, everybody is calculating in the metric system.
The metric system won out, did it?
Yes.
Yes, no, very important. Especially when there are so many different nationalities working with different conventions. It must be very important to have standardised measures so that...
Yes, of course.
Yeah, so you don't make
That's
errors.
the reason why we have this now.
Excellent. Jan Raack, that's all we have time for, but thank you so much for coming on. We're going to take a look at what you thought about extraterrestrial life. So this time we've asked a various range of questions about whether you think that, yes, this is specifically, I guess, in terms of life. Yes, they visited Earth or live on Earth. Yes, there was or is life on Mars. Yes, but not in our solar system, or no. So we'll see what you thought about the answers. And if you haven't voted on those interactive widgets, you can just select them, touch on the option that appeals most to you, decrease the screen, and you'll be able to see what everyone else has also. And we'll have the results from that now, actually. So in the lead, we've got yes, but not in our solar system with 47%. And I guess a lot of this depends on the interpretation of life, whether we mean Martians or organisms or plants or etc. So very interesting there. Our next guest coming into the studio is Matt, but before we do that, Sophie and HJ, how's it all going on the chat? Are things a little bit more sensible now?
No, I think we've hit a new low. we started talking about My Little Pony. And I'm actually quite worried about how much HJ knows. So I've got a little sister. It's all, she's 6. Oh, well, that would explain it.
Yeah,
but
I never have any enjoyment watching that show.
Knows all the characters, and you even have a favourite, I believe.
Well,
Which one? I know all about My Little Pony as well. Which one?
Well, I think everyone has to know that Applejack's kind of cool. So yeah.
She's a monkey. She's always getting in trouble.
Maybe I relate somehow.
Why are you talking about My Little Pony?
I'm not even sure how we got there. I'm really quite confused. There have been some really good questions in the midst of all this madness.
Oh, yes, I have one, actually, I'm going to talk to my next guest about, which was about this whole idea of leaving... of Brexit and the impact in terms of involvement in ESA that I think would be really interesting to start talking about. So everyone's happy, are they, in the chat?
And I think we are ready to talk about the future as well, grounding ourselves again. Davin's talking about if we had a colony on Mars, would resources like metals and minerals be usable with all the radiation reaching the surface?
Paul has asked a really good question, actually, about whether a magnetic field could be placed back on Mars using technology. And she's also asked whether humans, if they were born on Mars, could they then evolve to live outside of a habitat that we place there, for example? Would they be able to evolve to live on Mars without the necessarily scientific...
I think someone else brought up, interestingly, about the psychological stamina required to go to Mars and live on Mars in such a harsh climate. So there's all interesting stuff, and I think we're very interested and excited to start this.
In the midst of our madness, there
yes,
is some,
there
are
some
some people
stuff
there who are keeping us grounded this time.